We've always looked to the stars with questions. Hewlett Packard Enterprise is helping answer them, providing physicists with enough compute power to map the universe, unlocking its secrets to better understand our place within it. When everything computes, what's next is extraordinary.
Good morning, everyone. 79 years ago, two men took a decision that would not only impact their lives, but would actually impact a whole industry. These two men decided to stop their studies, to stop with university, and to start their own company. And the reason why they did so was that they were actually encouraged or motivated by one of their teachers or professors at university who wanted to re-energize the region where they were living. So this professor actually gave them the free use of his garage in the backyard of his house. And so these two men started to work day and night to produce their new product. And they succeeded. And what they built is actually an oscillator. So what would you use an oscillator for in 1939? Well, they sold it to the Walt Disney Company. And Walt Disney would actually use that piece of equipment to do some special effects, so special sound effects, in the cartoon movies they were producing at the time. And this is how Bill Hewlett and Dave Packard created the company. And this is being considered as the moment, the time and the space when the Silicon Valley was created. And we all know how many companies, great companies, were born in the Silicon Valley. So today, as the president and managing director of Hewlett Packard Enterprise in France, I'm extremely pleased to tell you that Hewlett Packard Enterprise is thriving. And I think it's remarkable. We all talk about startups, but if you look at the SAP 500, the average age of a company in the SAP 500 is under 20 years, right? This is down from 60 years in the 1950s. So obviously, we changed a lot as a company. And today, the strategy of Hewlett Packard Enterprise is to help our customers making hybrid IT simple on one side, and on the other side, to power the intelligent edge. Because a lot of interesting things are happening on the edge of the network. Edge computing is going to be a big thing tomorrow. It's already today, but it's going to get even better, even bigger. Today, we live in a world where everything computes. Everything is producing data. Your watch, your car, your fridge, your television, sensors everywhere are producing on a daily basis 2.3 billion gigabytes of data. And that is giving us tremendous opportunities. That is giving us opportunities to solve some of the world's biggest problems. That is giving us the opportunity to do, like President Macron is saying, tech for good. Let me give you one example. Alzheimer. 46 million people impacted by Alzheimer across the world. And we all know how bad this disease can be. And actually, with Alzheimer, when you've got the symptom, actually the disease has been starting probably 20, 30 years before you really feel the symptoms. So we've been partnering with an institute in Germany, the DNZE Institute in Germany. And the mission of that institute is very simple. It is to cure the Alzheimer's disease. And one of the challenges they've got is actually data processing. They're producing huge amount of data, blood tests, genome sequencing, brain scans, right? And the challenge they've got is really to be able to correlate all this data and find new ways to cure the disease. And they came to us because one of the biggest problems was actually the time it took them to really analyze one of the key part of the data. It took them 20 minutes, which was a critical process for them. So working together with them, we've been able to shorten it to basically 2 or 3 seconds, which made a major impact on the productivity, obviously, of the scientists, but also on gave them new ways to do innovation. But to jump into the core topic of this presentation, one of the key mysteries we've been trying to solve for a long time, actually, has been obviously a better understanding of the universe. So if you want to understand the universe, one thing you can do is obviously space exploration. So we sent people to the moon. We sent people to the moon a while ago already. And now the next frontier, obviously, is going on the planet Mars. We all know we've heard Elon Musk and others who want to send spacecraft to Mars. And it's actually people are starting working on that topic. And you've got a number of challenges. You've got a lot of challenges if you want to send a mission to Mars. But one of them is obviously the time it takes to get there, and things are improving. But it can be 100 up to 100 days. Another point as well is the communication of your data from Mars to Earth, where in the worst case it can take you 24 minutes to send your data from Mars to the planet Earth, and then 24 minutes to get it back. If you're in trouble, that is a hell of a lot of time, obviously. So there is a simple answer to that, a solution to that, which is obviously having the right computing power during your mission to get to Mars, and then doing a lot of the data, the lab analysis, all the things that the scientists want to collect, to process a lot of that information on the ground on Mars. That looks very simple, right? Well, it's not. It's not, and it is not for different reasons. The first one is solar radiation, obviously. Solar radiation, you may not know, but actually solar radiation is impacting heavily the way a computer would work in space. And the other one is very simple, is energy. You've got a lot of solar energy, but nevertheless, you want to make sure that you've got the best possible energy consumption so that you can send the biggest computing power in the mission. So the NASA approaches, and we've been working together on a project, and we've been sending with SpaceX, the SpaceX Dragon rocket, a supercomputer computer on the International Space Lab or Station, with the objective just to work on energy consumption and basically to see if we could have a standard supercomputer where we tune the software and if it could resist solar radiation. We sent it about 250 days ago. It's been working really well, and so well actually that we're even thinking now about the next step, which is bringing artificial intelligence off top of the computer so that you make the data analysis, the images, everything which is collected even more efficient. But the good news, obviously, is that you don't need to go to space to better understand the universe. And you can do a lot on staying on Earth, obviously. And what we've done with Hewlett Packard Enterprise is that we've developed a partnership with the Cambridge University, and more especially with the Cosmos department, which was created by Stephen Hawking. The mission of that department is very simple. It's to better understand space and time, things like the black holes or the origin of the universe. And our job at Hewlett Packard Enterprise, what the department, what Cosmos asked us was very simple. You need to process 14 billion years of universe data, which is basically, the time that separates us from the Big Bang, in order to help us better understand the universe. And thanks to that partnership, we've been able indeed to really, find some new findings. And it's been really exciting. It's so exciting, actually, that we've decided to invite a special guest, actually, to explain us these findings, the progress we've been making. I would like to welcome on stage Christophe Galfard. Christophe, that most of you must know, is the most French popular scientist, physicist. He's also a great writer and a great speaker. Christophe, welcome on stage.
Thank you very much, Gilles. So yeah, I've been asked to talk to you a bit about physics. And Gilles told me that everybody here is like super bright. so that I will assume that you all have some basic knowledge in quantum field theory in curved space-time. Do you? Good, good. So when you try to understand reality, what do? Are we very different from our ancestors? We're not. The way we understand things around us depends on what we can detect. And this goes through our senses, our eyes, our touch, smell, things like that. What we can see and feel through our bodies is exactly the same as it was for our ancestors tens of thousands of years ago. So what has changed? If I ask you to picture the whole universe in your mind, there are two things you need to think about. One is what the universe is, space and time. The other is what it is made of, the matter that are in our body, the matter that is around us, the air we breathe. If I ask you to picture space and time, what do? You see space, which is the distance between me and you, and that's fixed. And time is like a universal clock that ticks the same for everyone. And if I ask you to picture matter, you will picture something, the smallest amount of matter you can think of, that will look like a small, round, dense thing that is in the very small. Well, these two aspects of our reality have changed in the last century. For space and time, we know they are not what our intuition believed they are. In the very small, we know that matter is not what we think it is. It becomes quantum physics, where you're not talking about matter, but clouds of probabilities. Thanks to these two, like space and time understanding and the understanding of matter, we managed to understand where everything we are made of comes from. We understood that the atoms that make up matter were built in stars cores that exploded a long time ago. We understood that the Earth is made of dust from stars that exploded a long time ago. We understood that everything that is around the sun is made of the same matter as the Earth is, with some exceptions, with some minerals that are more present in some places than in others. What we've understood, thanks to the history of the Earth, is that resources, if we need some, are plentiful. There are minerals and resources everywhere around us in space. About 200 years ago, this didn't mean much. Like, to go to the moon sounded like pure fantasy. We went there. Now, to mine or find resources in outer space, we don't really need it as of now, but we definitely will. The resources here on Earth are finite. Out there, they're infinite. We can find everything we want. So, is that the main reason why we want to go in outer space? Yeah, for entrepreneurs, that's a very good reason to think about. But when you think about science, what you want to do is to understand everything that is around us. And that is going to be one part of the equation. Sooner or later, so many companies are working on these problems. So sooner or later, we will send satellites to probe and mine asteroids and other planets. So how will we do that? Imagine you send, as Gilles said, some satellite, some robot to Mars. One place you would like to have a look at for space, for human colonization, for instance, are caves. So how do you do when you send a robot in a cave on Mars? How do you do that? You can't communicate with the outside that much. So you need your robot to be autonomous. You need your robot to be able to get deep inside Martian surface and check what's going on in there. Same for the moons of some planets like Saturn and Jupiter. Some of these moons we know are ocean worlds. We know that underneath a thick ice surface, there is a huge ocean of liquid water. We haven't seen them directly, but we've seen them indirectly. We know they are there. Is there life in these oceans? How can we check that? One way to look at it would be to look for things that we know on Earth, like, I don't know if you've heard of those black smokers, which are deep down in the ocean. They are smoking minerals through the deep oceans, and life thrives there. This is one of the places we think life might have been born on Earth. Such places we may find on Europa, for instance, which is a moon of Jupiter, or Enceladus, a moon of Saturn. How do we probe these places? We'd need to send a robot there. Once there, the robot would need to stay for about a year to melt through the ice and get inside the ocean underneath. And then it would have to probe the surface of the ocean under the ice. How can something do that? It would have to be autonomous. Gilles was talking about 24 minutes when the worst distance would have to be from Mars. For these satellites, the lack of communication can last weeks or months in a row. For this, you need autonomous vehicles. You need computing power to be able to change your mind, and the artificial intelligence to be able to recognize something that was not expected. One of the things that does slow down everything we do on faraway planets is that we are not even sure we could recognize the unexpected. Humans are very good at that. Robots are not, but they're starting to be. When people talk about artificial intelligence, there are so many different topics that this involves. Facial recognition, for instance, or object recognition, finding a way to change your plan and readapt it. If you have a robot on a faraway planet which suddenly sees something unexpected, it will have to change its resources, put the power into finding out what this special thing is. And for this, you need to make sure that you're not going to kill your robot by using all of its energy. All these problems entered the artificial intelligence network of trying to figure out how to colonize and probe the entire solar system in the past few years. And it's starting to work. We're starting to have robots that have that ability. Now, to be able to react in real time, you need the computing power to do it on site. As we were saying, 24 minutes, worst case scenario with Mars. When we're talking about faraway planets, it can be hours. And when we're talking about finding out what's happening on moons far away, we're talking weeks or months of autonomous behavior. These are exactly, I think, what we will begin to witness. We will be most probably the first generation of humans to see faraway worlds being probed by an intelligence that is not biological, that we created. This is the way to go. We can't send people. People are far too expensive to sustain in outer space, and you just don't want to send someone to Mars like that. You need robots first to do the thing. You even need, in the end, robots that will be able to build things in space without human intervention. This is one way to create the future that will happen in space. It is so expensive to take stuff from Earth and bring it in space. Why not construct things from space to space? Take the minerals, take whatever we find out there, the metals, anything in space to build spatial stations all around the solar system. I'm pretty sure that's what the future will be, and a future that is not so far away. It most probably will begin with scientific research, but very quickly it will become something that businesses will want to get into. Now, to do that, we need computing power. We need huge technological leaps. And these are happening right now. It's very exciting to see it happening from a scientific perspective. And the other thing that we may do with these computing powers is that we can use them. The amount of data that we've gathered about our universe is so big. As Gilles was mentioning, we have some 14 billion years of data that is around us. To understand it, to see patterns that we did not see, those kind of computing powers will allow us, I'm pretty sure, to find new laws in nature, to find new ways to reach distant places, distant worlds. As of now, the fastest satellite that ever reached Mars took around 3 months or so. I visited some labs in the United States a couple of months ago where they use a new technology to propel large-scale spacecrafts, plasma technology. With these technologies, you can reach Mars in an expected 39 days. As of now, you'd need to wait for 2 years on a Martian trip for a human to get there, because it takes so long to get there, then you need to wait for Mars to orbit once around the Sun before you can come back to the Earth. Otherwise, when it's on the other side of the Sun, it's too far away. 2-year trip. With a 39 one-day trip, you can do the return within 6 months. That costs much less. I do believe that the future of computing, the future of technology, is going to help us discover the future for mankind. About 10 years ago, Professor Stephen Hawking said that mankind has to find another planet to colonize if we want to survive. And mankind has to find that planet within 1,000 years. He did say that at a press conference about 10 years ago. And then 3 years ago, he said, actually, 1,000 years is not good enough. We need to find something within the next 100 years if we want to not have all our eggs in the same basket. I believe that's possible, and I believe that all the technology that we see appearing right now will help in that respect. Not necessarily to reach planets beyond the Sun, but to reach planets around the Sun to begin with. I don't know, has any of you ever dreamt of traveling to another planet in space? I've seen all those who signed up to go on Mars 1 to be the first ones to colonize a planet like Mars. Would any one of you sign up for that? Yeah, a few? I think you're crazy, right? Because that's kind of a strange way of doing things. But humanity is so made that we always have volunteers to be the first adventurers in these kind of mind-blowing, changing, revolutionary things. And just as we found all the continents on Earth, I believe that within the next few years, we will become a multi-planetary species, even if it's just the 3 of you to start with. So thank you very much for listening to me, and good luck with all you're doing. Please keep on finding new technologies to get us into space.
So thank you, Christophe. I think that the objective today was really show the importance, obviously, of innovation. We see a lot of innovation here, obviously, that can help to solve some of our daily life problems. But there is also bigger innovation going on, maybe long-term innovation, and that has been really, really exciting. We talked about the International Space Lab. We've got a copy of the lab on our booth, on the Hewlett Packard Enterprise booth. It's really, really interesting to see it, so if you're interested. Christophe will be on the booth as well around 2:15 this afternoon if you want to interact with him. Thank you very much and have a great day.